Welcome to today's session. We're gonna be doing the rest of the question paper, and then we're gonna move on uh, to another question paper. So let's open the question paper and continue where we left off. Mm, okay, this is the memo. I want the question paper. Okay, so let's see. I think right now we're left with data structures and algorithms. Like this one, describe how a queue can be implemented using a linked list. Okay, I think we should do 2.4, 2.5, and 2.6. And then, okay, as for the DLL question, we'll get to that data. So let's see. So, let's see. Consider the following node-based data structure for the remaining sub-questions. Provide code for a templated node structure compatible with the data structure. So here is just the different. It's just using what we call data structures. So remember what a data structure is basically a way to it's a way to structure your data. You can use an array in such a way that the data is structured in a linear way. If you're using an array, it's linear. It's one way. It's just like one straight line. And there's other ways to structure the data. There's also like non-linear data structures. For example, your graphs, trees, yeah, all of that. So I'm just going to open. How do I find the page number? Okay, let's just check for the page number. String type, blah, blah, blah. Yeah, we're towards the end of the textbook now. So let's see. Record structures, inheritance, pointers, overloading, exception handling. Okay, there we go. Recursion, nope. Vector type, linked list. Okay, so we are looking for linked lists, right? So it's going to be page 1115. 1115. Okay, so there's linked lists. So let's just see what linked lists are all about. So let's see. So a linked list is just a collection of components, right? So those components is the things that you see on the question paper. If you check the question paper, these circles here, these are the what we call the components. Those are the components that they're referring to. And those components, they have a name, they're called nodes. And then every node or every circle, if you look at this circle, every circle, it stores the address of the next element. So it's like, for example, imagine you're in a neighborhood, right? You stay in one street, you have neighbors, right? So imagine if the only way for people to go to your neighbor's house is to go to you, since you will be storing the address of your neighbor, the person who's next to you, who's after you. So the only way that they would have to access or go to your neighbor is if they have to go through you first. Then you will give them the address of where your neighbor is. I mean, it's a weird example, but it's sort of like that. So just imagine this circles is like a house. Each person stores an address of their neighbor. That's exactly what a structure, what a linked list is. And with this linked list that we're seeing here, it's what we call a secular linked list. because as you can see, it starts from the head and then it moves on to each node, and then the last node at the end is supposed to be pointing to a null pointer. When it points to null, it means that that's the last node. It's not pointing to anything, right? That means D is going to be the last node. But as you can see, the arrow goes from the last node or this last house, and then it points back to the first house again. So we have a secular linked list. So it's going in seculars. It's a secular thing. It doesn't stop. That's what I'm trying to say. It doesn't stop. It's a secular linked list. So let me see if I can try and make an example. Let me see if I can try and make an example of this thing. But I feel like it's pretty straightforward because it's just the way information is stored is that one person stores the address of the other, the person who's next to them. So you can imagine this is the node, right? Or the house. This is the house, right? And then there's my neighbor. Then there's my neighbor's neighbor, and so on, right? Then you would have arrows pointing to the next node, right? You have arrows pointing to the next node. I think I should have used, okay, that's fine. Just it's a little too big. Okay, but it's fine. So as you can see, A, this one, we're gonna call that, yeah, we can call that A, whatever we wanna call it. Where's the text thingy? Yeah, insert text box. So we're gonna call this A. Come on. Damn, it's resizing the wrong thing. I wanted to resize this. This is so big though. Let me just double check something here. The font is so big. Let me just do it like this. Let me say insert text, right? Damn, that's too big. Yeah, it's too big. How do you resize this thing? But yeah, let me just enlarge. Let's just do it like this. Let me just enlarge these shapes to make it readable. Come on. Why is this thing so difficult to? It's unlike what is PowerPoint? PowerPoint is straightforward. But since I'm using Linux, Ubuntu, yeah, I'm gonna have troubles. Let me see. Okay, let me do this. Let's see if I can't right click and insert the well, this thing doesn't want to cooperate. So what I'll do, I'll just make the okay, let me just do this. Yeah, there we go. So we have our nodes or houses. Can just imagine the house points, each house points to each house stores the address of their neighbor. That's just, why is this being difficult now, this thing? You know, it's getting on my nerves now. You know what? That's fine, man. So it's like this. Each neighbor stores each house or each circle, or they are called nodes, but you know, in this example, we're gonna refer them to houses. So each house stores the address of the house this stores the address of their neighbor. So that's basically, in simple terms, that's how it's going to be. So basically, we're gonna need, if you check each value in our, you can sort of see it as like an array in a way. If you check each value in in our linked list, it's going to have two things. It's going to have the value itself and an address to the next house, right? So just keep that in mind. So let me do this. I think if I use these shapes, it's going to be a bit better. Yeah, let me just do this. Let's use this one. This thing doesn't want to cooperate. What's going on today? Today it's not. Insert, let's see. Field. Okay, so let's see. Should I say push button? Okay, let's say a label. So you can put a label like that. Okay, let me see if I want to put text. Okay, that's not what I was expecting. Arrange, blah, 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 control. Okay, let me check control properties. Um, da, da, da. Okay, this is not what I want. Let me see. Which shape is this one? Okay, yeah, I think this should be a bit better. Yeah, this shape should be a bit better. And then now I'm gonna add the oval. Yeah, so it's basically like this, right? Yeah, it's basically like this. I feel like this is a bit better. So this is, you can imagine this is like the house, right? I don't know why the font is so big though. So you can say this is like, okay. Okay, now the only thing that's missing is the text. Um, oh yeah, let me just decrease. Oh, so I can say, okay, so I see now. So let's add text here. You can say house. Why is it adding it on a new line? Control. I don't know why this thing is so weird. I did reduce the text size though. Decrease again. And then decrease again. Okay, so I'm just gonna use letters. I feel like that's the simplest way. I call this one a, like basically the way it's demonstrated from the question paper. So this is going to be house A. You can imagine this is house number, house A. That's the house. And then, okay, I should just copy all of this. Okay, didn't copy the text. And then this is going to be house number B. Okay, yeah, so I'm gonna do it like this. And then I'm gonna copy again. Okay, let me do this. There we go, copy. Okay, copy, paste. So we're gonna have that house and then copy paste. This is house C, right? This is house C. That's the name of the house. And then now it should be pointing, usually it should be pointing to nothing, to null. So the way I'm gonna represent null, right? It's still gonna be a circle, right? But then I'm just gonna change um mm, okay, let me just do this. Let's use a different shape for null. So let's just imagine null is just this rectangle. That's null. It's pointing to null if the shape is like this. But now just basically means it's pointing to nothing, right? And the way we go about doing this, right? So usually it's normally like this. You have each node pointing to the next node, right? You see the arrow, it's pointing to the next house. And then the last house obviously is going to point to nothing to denote that, okay, it is the last house. So this now part is going to be very important. So we have the house, right? And we typically want to know which one is our starting point. Just like with arrays, we know that the index 0 is the index 0. That's the first element in our array. So how are we going to keep track of which one is the first and which one is, well, which one is the last and which one is the first? Because I can tell which value is the last because it's the one that's pointing to null. So we're just gonna do this. Yeah, but it literally makes sense to come on. I want to resize this thing. Yeah. So you see, it points to null. Basically, null is nothing. It points to nothing. Then I know this is the last element, right? So how will we know that this is the first element? So basically, we're gonna update our head. We're gonna call it the head. So there's the head and the tail. The tail is where it ends. So you can imagine a horse, right? Or any animal. There's the head, that's where it starts. And then when you go, you can imagine this is like the whole body. And then when you get to the tail, you know, okay, this is the end. This is where the body ends. So you can picture it in that way. So obviously, I need to tell the computer that this is the head. So I'm going to have to create a pointer that points to this first value, and I'm going to call it head. So I'm going to create this. And then transformations, flip. Okay, it's not flipping it the way I want it to flip. Flip to vertical. Okay, this thing is not cooperating. Yeah. So let me try again. Okay, there we go. Yeah. So the computer is gonna know that, okay, this is the first element in my linked list. And then this one, I'm gonna call it head. It's the head. Come on, the thing disappeared. This is going to be the head. So as you can see, let me zoom out a bit. Yeah, you can see a bit better now. So we have the head where it starts, and then we have the tail. This is where it ends. You could technically do the same thing. Let me copy this. You could also do this and say, this is my tail. You could do this. You could do that too, so that it knows, okay, this is the tail, this is the head. But the tail, I feel like it's fine. You don't have to be explicit about it, because when the moment it points to null, you know, you yourself and you and the computer, you both know that if it's null, that means it's reached the end. There's nothing it's pointing to. So therefore, this node is going to be the last node. This one, it's definitely the last node. Okay, so we have the linked list, right? This is how it works. So let's say I want to insert a node, right? How would I insert a node? There's a lot of things that I'm going to need to update. So let's say I'm going to insert a node. And let's say we're inserting the node at there's many ways you can insert the node. Let's say we're inserting the node at the beginning, right? So if I insert it at the beginning, I'm going to do this. I'm going to literally create this. There's the value, right? There's the new node. And then I'm going to make the new node's address point to this first node, right? And then once I'm done, I update my head. Remember the head, it points to the first element. This node A is no longer the first element. This is now the first element. So I'd have to update this pointer here, the head. I have to update the head to point to, okay, let me just do this. So I'd have to update the head to point to this one, like this. And then there we go. I've inserted a node at the beginning. So you see all of these things that you are doing, changing, updating addresses, updating the head, updating all of those things. That's exactly what you're going to do in code. But it's good to picture it and see it as diagrams like this first before you. I feel like that's the only way you can actually know the code is by looking at the drawing. If you can remember the drawing, how the linked list is, then you definitely won't struggle with having to write the code because the code is just looking at this drawing and seeing, oh, okay, remember this arrows, it means the address. And then this circle, it means you can just say it's the value itself, right? So there's two ways you can go about representing it. You can represent it like this, or you can just say, for example, you can do this. You can do this, make it a bit simpler, right? Where you're gonna say, this is going to be, come on. Where you're gonna say the first value, the first box or the first square is gonna be the value, right? And then the second box is gonna be on gonna be the address. So you can view it like this. We can view it in this way too. It's one and the same thing. It's just that this second way that I'm showing you right now, it's a bit better because you don't have to think about a lot of things because everything is labeled in the right way. Okay, and then this. And then I'm gonna put that value down there. Yeah, like this. So you can imagine this is what you see, this whole rectangle here is equivalent to this whole node. Remember what I said, the arrow means the address. This the circle itself just means the value. So if I want to point to the next node, I would use the same arrow like this. Then it points to the next node. Basically, by pointing to the next node, all I'm saying is just this address here, it's the address of the next node. So let me just let's use let's do it in this way, this second way, because I feel like you can picture it in a more vivid manner. So I'm gonna delete. I'm gonna delete everything that's here. Then yeah, okay, let me do this. No, I want to copy the whole thing. Come on. Yeah, if your computer is not touch screen, yeah, you struggle with having to do all of these demonstrations. But let's just continue. So I'm gonna copy this whole thing. Come on. There's the next node, and then we're gonna have another node, right? Like this. It's just that the space that I have is too small, but I hope you can see it now. So we're gonna call, remember that each node has a name, right? So we're gonna call this A. Then we're gonna have B, and we're gonna have C. Okay, this is going to be B. And then this is going to be C. And then this is going to be A. So as you can see, these are the nodes, right? So each node is going to have two things: the value the value? Let's say it's 10, right? And then address the next person. So let's say the next person's address is 0x1, something like this. Because remember, it represents addresses in hexadecimal. That's how they are represented on your machine in hexadecimal, which is 16 bits or 16 zeros and ones. But yeah, 16 zeros and ones. But then it doesn't use bits to represent the numbers. It actually stores it as basically what, if you remember your slides, hexadecimal is basically using the normal numbers that we use, which is the decimal. We use numbers from 0 to 9, right? But then it also has letters A to F, which continues from 10 to 15, each letter representing that value. So A represents 10, B represents 11, C represents 12, and so on until you get to F, which is 15. So let's say the next value is 33. Then this one is going to, the address is going to be OX2, right? It points to this address. And then this value is going to be 99, something like this. And then this address is going to be now pointed. Basically, that's the address of the next node is going to be pointing to, because the node, so for this last node, I'm just going to use a circle, right? And then we're going to use I'm just going to use null for the sake of simplicity. Okay, not what I'm expecting. Yeah, there we go. Yeah, there we go. So you see now, it points to now, this is the address. So basically each node has the address of the next element. In simple terms, that's how it is. And then you're gonna have your head pointing to the first value, and you're gonna have your tail pointing to the last value. You could use the tail or you could not use the tail, it doesn't really matter. But yeah, obviously the tail is gonna point to this one, not this, it's gonna point to this. But yeah, you could do that. So in simple terms, this is how it's structured in memory. You take two things, a value and an address. And if you remember, just do a bit of background on pointers, right? If you remember pointers, how do we store an address in C++? We make use of pointers. That's how we store addresses. So let's say I wanted to store a pointer, an address, right? And remember how pointers work. Is storing an address. This is to store an address. The pointer there is important so that when you want to go to the address, you just use the pointer to dereference to go to the address. So what happens is that the variable name itself, in this case is just P, it stores the address, right? And then when you dereference P, what you're saying is that you're saying go to the address stored in variable P. That's what that's in simple terms, that's what you're saying. You're just telling it to point to the address. Remember, point basically means go to. Point to this address. So, like I said, addresses are represented in hexadecimal. So let's imagine the address here was 0x1, right? So if I want to if I want to go to get the value of that address, I dereference, I go to the address, I point to the address. So it's going to say point to, remember P is just 0x1, right? So it's going to say 0x1, point to 0x1. And point to basically means go to. So basically it's going to do what? Go to that address. And then when it goes to that address, it gets the value that's stored in that address. So let's demonstrate and see. So remember the way you initialize a pointer, you have to give it an address, because remember pointers, they store addresses. you have to give it an address. So there's two ways you can go about, there's many ways you can go about initializing a point. The first thing you can do, you can make sure that it's pointing to nothing at the moment. It doesn't have any address. And then you just give it a default value, let's say 50, right? This is the first thing that you can do. Then the second thing you can allocate memory for using the heap. You can say create memory for a new integer. If you're done creating memory for a new integer, then you give you remember what new does. It creates space. It creates a box to fit an integer, right? That box is going to be big enough to store an integer. Then now you store that integer within that box. That's what the new does. So I'm just going to use now pointer, keep things simple. And then now let's output. Let's see the address. I'm going to output P. Remember I said P stores the address. So here I'm expecting something that is OX, but hexadecimal. Remember letters from A to F, something like this. And then when I point to that address, I'm expecting to get 50 as my output, which is the value stored at that address. That's what I'm expecting to get. So let's do that. So G++, test CPP. I'm just compiling the application, the file. I'm just running the CPP file, but I'm not using an IDE. I'm just using a text editor. So I have to do this. I can either do this or I can just press the run button. Doesn't really matter. So now I'm going to run the executable. Remember that it's going to store an object. The binary code is going to be stored inside here. So I'm going to execute that file with the binary code. Segmentation fault. Yeah, let's just do it like this. Let's just make a new int, because now it's giving me the seg fault. Yeah, that's very common. I think there's something that I made. It should be working fine. Oh, okay, I see now. I see. Oh, okay, it's fine. Yeah. You see what I'm trying to do? I don't know how I forgot it. Yeah, I'm trying to point to something that's not pointing to anything. So it's you're gonna get a seg fault. It's called a segmentation fault, right? So when you try to use a memory address, that's not existing. It's not in existence. So you're trying to point to a memory address that does not exist. So you get a segmentation fault. So just keep that in mind. So let's just use the heap. There's literally many ways you can initialize this. There's many ways. This is not the only way. Yeah, I totally forgot about the segmentation fault. That happens, but yeah, as you can see, there's the address, right? As I said, it's always going to start with OX, 0x. Remember that 0x, it tells the computer that, listen, every value after OX is going to be hexadecimal values. As you can see, there's letters A, D, B, E, F, you see. And then second output was what? 50, because I told it to go to this address. And then it took a value stored in that address, which makes sense. Because obviously, if I want to find someone, right? Let's say I want to see my friend, I would have to go to where my friend is at that specific address. For example, it can be, okay, you text your friend to tell them, oh, I'm at the D lab. That's the address. D lab is the address. So if you want to find them, you'd have to go to that address called D lab. That's where you find them. So it's exactly the same concept. Because remember what computers did, what computers were made for. They're made for they're basically made to mimic us, to do the things that we people could not do efficiently. So for example, you can't calculate a very big number fast in seconds. You can't do that. You really can't. I know there's people who are gifted, but what are the odds of you being gifted, that gifted to calculate that fast? it's quite a few percentage. I would say roughly almost 0.1% of people who can calculate that fast, but they're still not as fast as a computer. Computer is extremely fast. So remember that the same concept that we use in our world. Okay, how if I want to visit you, for example, you want to visit someone you don't know, obviously you're gonna ask for their address. Where do you stay, so that they can request and go and come to you. You see, you need addresses to find that thing that you're looking for. In this case, you can imagine this is the address of your friend, right? This is the address of your friend, and then this is going to be your friend at that address. That's all that means. Your friend at that address, point to. So you're gonna get that friend at that address. That's basic. It's simple terms. That's what pointers are. So as I was saying, you use pointers to store addresses, right? So let's just let's initialize the pointer to 0, right? So the way I can initialize it to 0, I can just create a pointer, a value, a normal variable, and initialize it to 0. I'm using the C style format of initializing, but you could use the structure, or you could use the list initializer, the C++ way. There's many ways. There's many ways to solve the problem. Then now, when you're initializing this pointer, remember what I said, the pointer stores addresses. I'm going to get the address of A. That's how I initialize the pointer. This is the second way of initializing the pointer. So now the pointer is going to have the value of 0. So if I run this, right, I run it before changing the value. So this is going to be before. So I'm going to output before. This is before I change the value, right? And then this is going to be after. So I'm going to also do this after changing it. You're going to see that the memory address won't change, but then the thing that's going to change is the value. So let's compile it and then run it. As you can see, let me just zoom up. Okay, it doesn't want to zoom in, but yeah, as you can see before, you see it had the address of that other one. So basically it also had that value at that address. So it's going to be 0. That's the value. And then this was the address before, right? And as you can see, the address still hasn't changed because I didn't update the address. I just updated the value of that address. I just pointed to that address and then changed the value. As you can see, after changing the value is now 50. So that's that we're gonna use pointers to store the addresses. So just keep that in mind. That's very important to understand pointers. So remember what we said in the demonstration. We want to store two things, the value and the address. So how are we going to store that? And we want to create this data structure. We want to create a sort of like our own type. We want to define our own type. So which technique are we going to use? That's the question. The technique that we're going to use is the record structures. Because at the end of the day, I don't need, if you check, do I need functions here? No, I don't. I just need data. It's just two variables, a value and an address. That's those are the only two things I want to represent. So I'm gonna call it linked list because it represents my linked list. And then remember, it needs to store two things. The value, in this case, is going to be an integer, right? So that's going to be int value, right? And the address. Remember what he said, pointers are is the technique to use to store addresses. So I'm gonna use a pointer and then I'm gonna call it next. it points to the next node. That's why I'm gonna call it next. And okay, yeah, it's not int. It shouldn't be int. Remember what it's pointing to. It's pointing to another node, right? And remember, this node is gonna be called. Okay, let's not call it linked list. Let's call it node. Keep it simple. I'm just gonna call it node. So that's the node, right? Remember this two things, the value and an address. That's what you call the node. You're storing two things, a value and an address. That's the node. So it's pointing, the address is gonna point to another node, right? So the address is gonna point to another node. So I'm gonna use node type here, which means that this address that's going to be pointing is gonna point to another node. In simple terms, that's how it is. So here we're going to store the value and address to the next node. Basically, in other terms, you could represent it like this to keep it simple, right? So you could have a house, right? We're trying to create a house, something like this, right? And then each person is inside the house, right? So we're gonna have, okay, it's gonna be more complicated, but yeah, we're gonna have, imagine we have a person data type. So person, right? That's the value stored in that house. It's gonna be, there's a person in the house. And then now, remember what we said, if I want to store the address, I use a pointer. So I'm gonna use a pointer to point to the next house. So I need to point to the next house. So therefore the data type that this pointer is gonna be pointing to is another house. Another house. And it makes sense to say another house because if you check if you check, then each house, it has a value and an address. So I definitely have to point to another record structure that is an address, a value and an address. So I hope that clarifies things. I hope you really get what I'm trying to say here. But yeah, there's the person, that's the value, and then there's the address. It's gonna be the next thing in our linked list. And remember, it's called linked list because they are all linked. You see, they're all linked to each other. And it's a list, just straightforward, a list like this, but then they are linked to each other. That's the thing that you need to understand. So we understood pointers, right? So let's do, let's say we want to add an element, right? So, okay, let me see. I think, should I go through the slides a bit to the textbook? I mean, so as you can see, it's a collection of nodes. We explained that. As you can see, you can have a head that points to the first element, and then the last element points to nothing. You see, there's nothing that is pointing to. Then I know, therefore, I know this is the last node. As you can see, they say the down arrow in the last node indicates that this link field is null pointer. It's pointing to null pointer. So just keep that in mind. And then now when you want to declare the variable, you have to use that type that you created there, and then you make it a pointer. Because remember, we have to store addresses and an address and a value at the same time. And then there's many ways you can go about doing it. So let's see. Yeah, you can go through the slides and try to understand more. You can do that. So let's create the variable declaration, right? So we're declaring the variable. So I'm going to create a node on node point. Should I call it? Let me just call it What name do they call it? Okay, yeah, I'm just gonna call it. You don't have to call it the head. It doesn't have to be the head necessarily, but yeah, I don't know why they called it the head though. It shouldn't be called the head. PQ new node. Come on. Let's see. P. What are they doing here? Oh, they're trying to insert. Yeah, I wouldn't. We're gonna see how to insert step by step. So you're gonna have to create a new node, then put in information, and then you set the link, then blah blah blah. Yeah, so let's say I'm gonna have the a pointer that points to the first element, the head, right? And then I'm gonna have pointer new node, right? Create the new node. So before I create the new node, I can check if, let me see, new node, and then point to the next. It's gonna be a bit tricky now, so let's see. Yeah, link. Yeah, this is a lot of things to do. So you want to insert a new node, but then you can't just insert. That's the thing. You'd have to check if everything is, if you have to check if it's, there's for example, you don't have a head, right? So basically you don't have a new node. It's gonna be a bit tricky. So what I'm going to do is I'm going to check. Okay, let's just answer the question, and while I'm answering the question, I'm also explaining it. So there's the question, right? Provide code for a templated node structure. So they want it to be templated. So basically it should accommodate any values, not just integers. And you remember how we do templates? You just say template type name, type name t. Then this is just going to be some t value. And then remember that the node is now generic. So it's going to point to another generic node. So it should be like this. Then now, whenever you declare it, remember that you have to pass in the type. In our case, we're going to be using, let me see, they're using, they're using characters. So as you can see, the value is A, B. Yeah, so it's characters. So I'm going to have to use char. So like this, it's characters, right? So in our case, let me just do this. In our case, we have this node that's already there. The thing that I wanted to avoid was the thing that I want to explain is before we get into this is see how to insert if it's empty, right? So how do we check if it's empty? So what I can do is, let me see, will it allow me to do this? Okay, yeah, it does allow me. So what I will do is I'm just gonna make it point null pointer, right? And then I'm going to check if new node, right, is equal to null pointer. That means there's no node, right? Before I even try to do anything, I know for sure there is no node. There is no node, right? There's literally no node. So since there's no node, I'm going to create a new node. So I'm going to say new node is equal to new node type char, create a new node, right? Remember what he said about new. you're allocating memory on the heap. Allocate memory on the heap. And then that memory should be enough to store characters, right? But then it should be enough to store a whole node, this whole record structure. Should be enough to store that whole record structure. In our case, we're not going to be dealing with file handling and all of that. We don't have to do alignment padding to make sure that we get the exact same value on each operating system. We're not dealing with files here. We don't have to worry about that. Then now I'm going to initialize the value for that node, right? So I'm going to point to the node, right, and say, remember that it starts at A, right? And then is equals to that, right? So okay, no, I shouldn't try to point to, no, this is wrong. It's remember remember the pointer stores the address. So what you want to do is you want to go to that address and then set the value like this. Okay, let's explain it step by step. I'm skipping a lot of things. So this is what we want to do. We want to dereference, go to that address, right? And then dot value, get the value at that, get the value for that specific node. Then set the value to be whatever value you want it to be. In our case, we want it to be A. So we point to that node so that we get the node itself. Then after getting the node itself, we get the value and then we set the value. Because remember what he said. This is the node. When you get the node, remember each node stores a value and an address. So at this moment, I want to get the value. So I want to get the value. And remember, this can be abbreviated to, remember what we said when you taught about when you're doing object-oriented programming. The dereference and the dot is equals to just this arrow. So you can replace all of that for simple syntax. Like this. So you can just write it like this. As you can see, that's the value. And then it's not, remember that it's no, remember what's happening here. Let me demonstrate what's happening here. So I told the computer that there's no, I checked I asked the computer to check if this node is currently non-existent, so it points to nothing. And then if the result was that it points to nothing, okay, let's see. Come on. There we go. So what happened was there was a node, right? It was okay. There wasn't really a node. It was empty. Remember that I initialized it to null point. You see, I initialized it to null point. It was pointing to nothing. There was no node. Then this line of code, what it did, right? So you can imagine there was no node, right? So let me just do this. Imagine there was no node here. There was nothing, right? There was nothing. And then that's what that null pointer did. There was nothing, right? There's no node. Then I checked if there's no node, then create a new node, right? You see what it did? This one line, new node, it literally made the new node. So it literally did this. Though at this moment there was no values, right? Come on. Yeah. So there's no values, right? This is how it looks. It's empty. There's no values. So since it's empty like this, now we need to initialize it to a value, right? We initialize it to A. So I set that value, which is this box here. So insert text, right? So this is going to be A. going to have the value of A. And there's a couple of things that we haven't done yet. Remember this arrow, there's no arrow, there's nothing. It's just the node itself. So far, that's what I have. These 2 lines of code, that's what they did. They made this node and then they put the value of A. Now I want the address to point to null because at this moment there's no other. It's the first and last node because there's no other node. You see, there's nothing else. So I'm gonna make it point to null. Since there's no other node, it's gonna point to null. So I'm gonna take this. Come on. It's just going to be null. Yeah. And then insert text. It's going to point. Okay, let's not call it null. Let's call it null pointer, the C++ standard, C++ way of representing nulls. Yeah, this is more like it. There we go. So this is what I want to achieve. I want to set the point, the address of the next node to point to null pointer because there's no node at the moment. So it's going to, I'm going to say new node, right? Dereference the node so that I can get the node itself. Then set the node, that node's value, the node's address, which is next. Set it to be the pointer. Set it to point to null. So this one line of code that I wrote here, it did this. It made it point to null because that's the only node we have at the moment. So since now the next node's address points to null, I need to also update the node. I need to also update the address for that node. So now this one points to null pointer. That's the address that it has. And then we also need to set the head. Remember, we have the head. I need to set it to the first element, right? Because at this moment, this is the first element. So how do I do that? It's the same thing. So I get my head, and then I dereference, and then I access its address, right? I want it to store the address of the new node. So I'm just gonna copy this and say new node like this. So now what this line of code does, it points to, it does this, what I'm going to demonstrate now. It comes here and then it does the address, which is just the arrow like this. And then insert text. And then this is now the head. I've set the heads next. Remember the head is also a node. Okay, so since it's also a node, let's just label it the right way. So it's literally like this. It now points to, I'm just gonna say address of A, right? And then remember, this is just a head. It shouldn't store any values. That node is not meant for storing values. It's just meant for keeping track of what's the first node in my linked list. So there we go. That's the head. It has the address of A, not necessarily A. Let me just call it the way. Okay, let's just say A because if I say new node, might end up forgetting, but you might end up being confused. But yeah, let's just call this is node A, right? Yeah, we're just gonna use the values themselves to represent the node. So far, this is what we have. So far, this whole line of code, these 4 lines of code, this is what they did in memory. So you need to understand, that's why I was saying you need to know how to label your diagrams properly so that you know how to make the proper changes. So now we have the nodes, right? So now let's insert the values B, C, and D. So insert, okay, before we do anything, right? Before we do anything, how do we how do we traverse, or how do we go through the linked list? It's simple. You create a node that keeps track of the current node, right? To be of the same type. So I'm gonna call it current, right? Because it keeps track of the current node. It's gonna start with the address of the head. Remember, don't forget, don't be mixed up here, don't be confused. Remember, I'm working with pointers, pointer head. Remember what I said. If you go back here, if I use the value of P only, you see P only, I get the address. If I point to that address, I'm getting the value. So don't be confused. When I just write head like this, I'm saying the address of head. That's what I'm going to initialize the current to. So it's going to store the address of head, and of which the address of head is the address of the first element. So that's what it's going to do. And then now I'm going to do a while loop. I'm going to say while current, right? Next, the current, while the current pointer, its next address, that is, while the current's next address or the address is pointing to, it's not pointing to null pointer, then I should what? See out current value like this. I should output the current value. And I'm not using standard namespace. I need to specify which which namespace is coming from. And then, yeah, while it's not pointing to, remember the next address, right? It's this arrow. That's what I'm saying. While this arrow is not pointing to now, keep going through the nodes. In this example, this node, the head is not pointing to now, it's pointing to this one. So it's actually fine. It's gonna work. And then now, how do you, the question is, remember with arrays, you if you want to move the next element, right? You'd say I++, or row++, or column++. This is how you'd move to the next element, right? It's similar to that, but then it's a bit, you need to understand a bit more what's going on. So what I can do is I can change the current address to point to the next node. That's it. That's the simplest way to move to the. That's the simplest way to move to the current address, right? Remember, the current address is pointing to the head. So I'm gonna say the current address, right, to be updated and point to what? The next address. Next. So this is equivalent to me saying I++. It's equivalent to doing that. But what does this mean? I mean the current address, right? Remember, the current address is pointing to head. So update head's current address, or the first element's current address, and make it move on to the next address, right? So what's going to happen is that, remember what I said, the head points to, this is the address that current is currently pointing to, right? Then it's going to output, look at our code, it's going to output the current value first before changing the address. So it outputs A. And then now I'm going to update this address, the address that current is pointing to point to the node after head. What is the node after head? It's this address, right? So what this is pointing to, I'm going to take that value. It's currently pointing to null pointer. So what's going to happen is that it's going to go back here and check. Okay, let me re-explain it again. So remember, the current node, it starts with the head, right? The head's address. What is the head pointing to? It's pointing to the first element. So I'm going to take that address that head is pointing to. It points to this. And then I'm going to update my current to point to the next node, right? In this example, you can see that the next node after, remember that we start pointing to the head, which points to A. So basically, I'm pointing to A. So I'm going to point to A at first, right? Once I'm done outputting its value, I move on to the address that it's pointing to, right? To the next node, which is this node, which is the null pointer node. And then I've moved, right? This is where I've moved. Then it's going to check, is the node's next address not equal to null pointer? No, it is equals to null pointer. Then it's gonna stop. So I'm expecting it to only output one value, which is A. So let's do that. Let me see. There's a lot of outputs here. It's not outputting the way I want it to output. I think, let me see. I think I shouldn't be. Oh yeah, I see now. I see the problem. I was thinking about it, but yeah, it's gonna be a problem. So yeah, you have to bear with me. This thing, you need to really understand what's going on. So what's going on is that I'm pointing to A, right? And then I'm checking the value of A. I'm checking if the value of the A's address. Remember, each node is pointing to the next address. So I'm checking A's address, the address that A is pointing to. If it's not pointing to null pointer, then do this. But then this is going to be a problem because it's A is already pointed to now. So there's gonna, I don't think it should even be working. Like shouldn't be even be outputting anything. Because remember the head points to the address of A. And then the address of A, the address after A is point now point. So there's gonna be issues there. So I feel like I should add more elements before I try to traverse the node, right? Because at this point I only have one value, so there's no need for me to even be using while loop. So let's just add all of the values, right? So let's add B. Let's add B. How are we going to add B? That's the question. Let's look at our diagram. We're gonna need to update the address. Remember, we want to add them in sequential order, right? So I'm gonna need to update the address of A, and make it point to the 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 new node that I'm going to add. But then before we do all of that, I need to create a new node here to point to. I can't just say point to a new node that I haven't created. So let's do that. So I'm going to say node, then let's call it B, right? Pointer B, right? So that's the node, and then I'm going to tell it to create a new node, right? Of like this. So now this new node exists. So now this is what's going to happen. Okay, so far we haven't, yeah, we don't have to worry about all of that because so far we haven't done that much. So now we have this node, right? That's what that one line does when you say is equals to new. This is what it does. Creates a node that can store characters as its value. Because remember, we're using generic. I told it it should store characters as its value. And then now I need to set its value. So its value is going to be the character B, right? So I'm going to dereference and access the node, then change its value to be the character B, like this, right? What happens? What happens in memory when I do that? This is what happens. Comes here and then it adds that value B. So now it's of this value B, right? And then now we need to start updating the addresses now, because now we have the value, we have everything. So now I need to update this address to now point to this one. So I need to put the null pointer somewhere there. I want this address to now change and point to there. So I want it to be something like this. Yeah, you see, to be something like this, to point there. I wanted to do that. But for simpler demonstrate this in a simpler way, I'm just going to move it up here like this. So we change one thing at a time, right? So I'm going to update this address, the new A's address. So to not be confused, let's call it by their letters A, B, C, and D. So I'm going to say A, then A, then A, then A, okay, I changed too quick. Okay, the head is fine. Needs to be A there. Why is it saying int? Oh, I see now. There's this conflict. And so let's say num. Let's change that to just num because it thinks it's that it thinks I'm referring to that integer at the top, of which I'm not. So yeah, let's leave it like this. So this is fine. So now we know which node we are referring to. So now I'm going to change A's address to point to B's address because I want to create that link. So I'm going to say A's next, right? The address that A is pointing next to, it should point to the address of B. And remember what I said, with pointers, if you just use the value, that variable itself is just the address. So this is perfect. So make the address at A point to be the address of B. So it should point to B basically, and that's what I'm doing there. So that's what that one line of code does. It points to B. So now it's going to update this, and then it's going to have the address of B. Then I should change this to a small letter because we're using small letters. So it has the address of B now. So now B should point to now point because now it's that new node, right? So I'm going to say B's next point to null pointer like this. So when I do that, it's going to copy this, going to an address like this, and then say now. Yeah, so that's what it's going to do. Like this. So now it points to this, right? So I need to create that error. It has the address of null. So I need to do this. There we go. So now it has the address of null. So there we go. I've indeed inserted an element after the first element, right? So now I have two values, A and B. So I think now it should be fine. It shouldn't give me problems. No, I shouldn't say current and the next value. I should just say current. Yeah, I think that's where my problem was. I should say current. If the current address is not pointing to null, then keep outputting the value. I think that's where my problem was. So let's just do it again. There we go. We have A and B. It outputs them as expected. And it stops. You see, it doesn't continue trying to access something that's now. It stops. As for this, I don't know what that is. Where is it getting that output? Yeah, I don't know why it's outputting that's that weird thing. So yeah, it points to the head, right? It starts pointing to the head. That's where it starts. So let me see, let me just double check something just to make sure it really works. So let's say I only have one element, right? Yeah, there we go, there's A. Yeah, that's where the problem was. I made a mistake there. Supposed to say if the current address, remember when you have a pointer variable, it stores an address, right? So the name of the variable itself is the address. So if I just use current, I'm saying the current address, if it's not equals to now pointer, then output its value. Then move to the next address. Then check if the current is not pointing to now, output a value, move to the next address. And then it checks, okay, current is now pointing to now, then it stops. So that's the way to traverse or go through the linked list. Then we can also add values like B, C, and D, right? Using this very same concept. It's just that for me to demonstrate here, it's going to be, okay, it's fine. I'm just going to start going down like this. Okay, it's fine. I'm just going to create a new node here and then starts going down like this because I'm running out of space now. So there we go. I did insert B, right? So let's add C. Add C, right? I need to use a different name. I can't reuse the same name, or else it's gonna have conflicts, right? So let's just do it from scratch. So at the moment, I'm going to, since I'm inserting a new node, right? I'm gonna leave this now pointer just stranded for now, just somewhere there, because I want to insert a new node, right? Before I can insert a new node, I need to tell it to allocate memory for a new node. So it needs to draw a shape like this, right? It should be big enough to have value and an address. So far this is what I have. That's what this new node does. It has that, right? This new node. Then now for that new node, I need to add its value, which is going to be C. So remember to add a value, I get the node. And remember when you say pointer followed by the name of the variable, you're saying point to that address. Here I'm just saying get actual node itself, right? Then once you've gotten the node, I want you to get its value, then assign it a value. So after dereferencing, I say dot, I get its value, and then I say is equals to assign it a new value. But then remember what he said, this can be abbreviated to like this. Dot value, we say is equals to C, right? I want it to store C like this. Then there we go, we've added C. So now if you go back to our diagram, let's add the value C. Copy. So now we have this value C. So far this is what we have, right? Now I need to, since I've set the value, now I need to update the pointers. So I want this value, this address of B to now point to C. So let's do that. Address of B. So how do I get the address? I get the node itself of, I get the node of B, right? Remember the node of B's next was previously pointing to now pointer because it was the last element. Now it's no longer the last element. So I have to update it and make it point to its address, make it point to the address of where C is located in memory, right? So now what this line of code does, this one, update the address of next for B. So it's going to point to the address of C, right? That's what I did. So therefore, I need to drag and drop this to here so that it literally points to C. There we go. Now it points to C. But then now I need to tell the computer that C is now the last node by updating C's next to point to now pointer. Because now the only thing that's left is this. I'm just going to add the arrow like this. So I'm going to update C's address to point to null pointer. So let's do that. So C's address point to null pointer. So now C is the last element. It behaves as like the last element because that's the last element now so far because we haven't inserted anything. So what happens is that it's going to, let me just click here and click insert. It's going to take the address of null pointer. So basically it's going to point to null. Okay, so I want it to flip like this. There we go. Yeah, there we go. So yeah, there's the diagram now. It has been updated. I have inserted C. It now points to the address of null pointer, basically points to null. So now if I want to add D, the last one, now you get the flow. So let's add, okay, before I add D, let's see if it's going to output. Okay, so now I don't want it to output like this. I want it to mimic this diagram like this. So what I'm going to do is I'm going to, when I'm outputting, right, I'm going to separate it by this. I'm going to make it have an arrow like this. So it's going to point to the next value. So what I'm going to do, right? Okay, you don't have to do this. I just wanted you to see it properly. What I'm going to do is I'm going to check if current next, right, is not equal to now. Therefore, I know I'm not at the last node, so I can add this arrow after. Else, that means I'm at the last node. So therefore, I don't need to add that arrow there, like this. You'll see the difference in the output. I'll show you this output now without, I need to put an end of line character. The thing that I'm doing here, okay, standard. The thing that I'm doing here is that I'm saying, if my current, remember current stores the current node. If the current node's next address is not pointing to now, then I know I'm not at the end. Therefore, I can add that arrow at the end because I want it to be like this: A, like this; B, like this; C, and then once I've reached the end, I don't want to add this. I don't want it to be there. That's what I'm avoiding. So that's what I'm saying. Remember, C is the last node, and C is next, right? C is next is gonna be pointing to null point. So therefore, you don't add this arrow at the end. So it's just gonna be like this. That's what I'm looking for. That's why I'm going through all this trouble of outputting it like that. So let's test it. So there we go. It's fine now, but I don't get what's going on here. Something is off here. I don't know. Something is not okay. So let me see. Did I set heads next to be correct? Yeah, I did set the head to point to the address of A, right? So it should have a node. Yeah, it should be pointing to the address of A. It should be pointing to the address of A, and then to add B, I set the value. I changed the A's next to point to B. Then I changed the B's next to point to null pointer, which is perfectly fine. This is also perfectly fine. So could it be here? That's the issue. Yeah, I see the issue. You see where the issue is? Remember that I'm pointing to the head at first, and the head has no value. Yeah, the head has no value. That's where the problem is. So it's outputting that weird character there. So there's something that I need to fix here. I can fix it in one or two ways. I can start at the head, right? And then I move to the next node before I output so that I can move to A, right? And do it like this. I start by moving to the next node, then I output. I can do it like that. So let's just check. Okay, it's gonna give me an error. Okay, I need to fix something here. What am I missing? So, yeah, let me see. If I point, okay, let me just double check the notes, but I think everything should be fine. Insertion, consider, suppose that P points to the node 65, right? Yep. Okay, I don't know why they're using so many pointers here. There's a lot of pointers. So let's see. Let's say you want to insert a new node, right? So I'm gonna say new node. Okay, blah blah blah. Building, don't care, don't care. This is a lot. It's a lot of unnecessary things here. Just looking for one thing. Uh, Come on, come on. Pointer to deallocate. Okay. So temp is equals to first. Then you make the for the first move, and then you delete. But last is equals to. Okay, perfect. Current. Set current so that it points to the first node. Yeah, and let's. I'm not gonna. Okay, yeah. Now I see. So what are we going to do, right? I wanted to point to the first node. So the way I'm going to point to the first node, right, is I'm going to use the heads pointer, which points to, it points to the next node, but it should be fine though. I don't know why it's giving me this. Let me think about it. It points to the address, it points to the address of the head. No. That's, I see where the problem is. I was actually taking the address of head, not the address that it's pointing to. So I was supposed to take its next address, not, yeah, I see the problem now. I was supposed to say next like this. So now I take the value of the address that it points to, which is next. Then therefore it's gonna take, I'm gonna take the address of A, the first element. Yeah, it was a small issue there. Yeah, there we go. Now it's fine. Yeah, I was supposed to take the, you see what was going on, right? What was going on is that what was going on is that I was taking the address of head itself. I don't want the address of head. I want the address that it's pointing to. So I would have to take the next address of head, then I start moving. Yeah, that was a small issue that I had made. But yeah, now it's 100% perfect. So let's also insert C now. Insert D. So insert the, yeah, you can I call it insert or add, whatever you want to call it. So jar and then pointer D, right? Goes to new node of type jar. Okay, so far we haven't answered the question. I'm just showing you how it was inserted for you guys, step by step. So new node. Remember the first thing that we need to do. Remember this line of code, what it does, it creates the new node. It draws that new node, right? So for now, since I'm adding a new node, I'm gonna put this null pointer somewhere there in memory. It's still there, it's still here. Okay, let's just leave it there. Let me just show you what actually happens in memory. It's still there, let's leave it there. All I have to do is create a new node. So I'm gonna copy this, create a new node, Okay, the new node. There we go. Yeah, I have the new node. It's empty. And remember, the first thing that we need to do is initialize its value. So I'm gonna get the node, right? Dereference it and access its value and set its value. Its value is going to be D. Therefore, when I go back here, I'm gonna select okay, something okay, now it's fine. So this is going to be D, that's going to be its value. And then now we set the pointers. So let me just set the first pointer. So now C should point, C is next value, or C, the address that C is pointing to should now point to the address of D, right? So I'm gonna go back here. So now this gets updated. So this is what's happening now. The address of C now points, okay, before I move it, let me change the address here to be the address of D. So now it stores the address of D, then this gets transferred here because now it's pointing to that address, right? So now it points to D, right? But then now D is the last element. I have to make it point to null. So D is next, or the address that D is pointing to should now point to null since it's now the last element. So now this is what happens. The address here gets updated to be the address of null pointer, right? And then since that's the address now, I'm gonna have the arrow that points to null. Then there we go. The command, yeah, there we go. So now this the value D is that D's next address, or the address that D points to now points to null pointer because D is now the last element. And then we're going to keep doing that. If you want to insert, you're going to keep doing all of that. So now we have all of the values. So now when I run it, it's going to output values from A to D. Now, so let me run it again. I'm not accessing a null pointer though. Everything is fine from my perspective. Let me see. So I set the value of D to me, that letter D. And then I set C is next to no longer point to null pointer, to now point to D, right? And then I set D is next to now point to null pointer. Everything is fine though. Yeah, everything is fine. I did create a new node. Why is it saying I'm not accessing a null value though? Yeah, because it's telling me that I'm trying to access a null value. Remember, that's what that segmentation fault means. Pointer D. It's save my file. How can I have a segmentation fault here? I just created a new node pointer, right? And just say new node, store characters. And then these next should point to null pointer. 100% fine. Okay, let's just do this. Let's see something. Yeah. Okay, it's still giving me that issue. So is the issue with this new code that I introduced or what? What did I change? I didn't change anything. Yeah, I didn't change anything. I don't know why it's doing that now. Okay, so something's not right with the way I'm inserting this new node. Let me see. So I create the new node. I set its value. Remember, the new node is pointing to this. I set the value of D, the value to be the character D, right? Everything's still fine. Then I change C's pointer because D comes after C. So I change C's pointer to point to the address of D. Then I change the address of D to point to null pointer. There's literally nothing wrong here. Why is it giving me segmentation fault? Okay, give me a second. I'm trying to figure out what the issue is here. So we have a node, create a new node. Shouldn't be a problem, should be straightforward. Set its value. Okay, let me just say, just use a different name. I don't really know these things. Could be the names, I don't know. Not sure why it's doing that. Okay, let me build again. Segmentation fault again. I'm just adding a node though. There's literally nothing missing here. I'm just adding a node. Allocate memory on the heap. I set the value of A's value to be A, character A. And then A's address that is pointing to point to null point. And then heads next to point to A. Then that's fine. Then insert B. I create a pointer called B, set its value to B. I set A's next to be B. And then B is next to be null pointer. Because at that moment B was the, well, I'm not sure what's going on here. What am I missing? I set it to be the value of D. And then let's see. I give it a value of D, and then I change C's next to point to D. C's next points to the address of D in memory. And then D's next points to null pointer. So D becomes the last element. I don't know why it's doing that though. Let's if maybe it's the way I'm outputting. Interesting. So let's see. The current X is not 22 now, then I know it is not the last element, then output. So it's telling me that I'm accessing memory I'm accessing a null pointer. How though? How am I accessing a null pointer? By just introducing a new node. Yeah, I'm not accessing a null pointer. Let me see. But I don't think it's the for loop though. The way I'm outputting, I don't think it should be an issue. Yeah, that's not the for loop. I think so. Basically, it's complaining that I'm accessing a null pointer. Let me see. I'm not though, because I'm indeed updating C's next. There it is. C has been updated. New node, new node. Just give me a sec. How long has the session been? Wow, yeah, nodes are linked list are demanding, but yeah, let me just try and fix this error, then we'll start answering the question, because at this point in time we haven't answered the question. I was just trying to show you step by step how you insert, how you do all of that. Even deleting is the same process. You just need to play around with your diagram. If you know your diagram, then you shouldn't have any issues. So we have this value. Okay, obviously t is not null. I give it an address on the heap. It points to the heap, and then I change this value to be that character. And then C is next to be the value D, to be the address of D. And D is next to point to null pointer, because that's the last node now. But when I add this code, it gives problems. Why? Why is that? Because after removing it like this, it starts working. See, okay, let's see. Just create it from scratch again. Maybe it's something that I missed. I don't know, but I'm pretty sure I did everything. So a new node, right? I create a new node, represent D. I think the issue starts when I just one line of code just messes up everything. Yeah, that one line of code. I don't know why it's complaining when I say new node. Okay, let me just do something here. Okay, it still gives me the segmentation fault. Okay, so I'm just gonna leave it like this. Let's remove this code at the top. Build it again. Okay, it is outputting, so this part is not complaining anymore. So let's try it again. So D is equals to this value. set the value of D. Then remember that now I need to update C's next to point to D now, because C is no longer the last element. Let us see. Now point to the address of D, and then D should now point to null pointer. Like this. There we go. I think what's the issue was is I have many pointers, and yeah, so I think there was conflict or whatever on the stack or on the stack. Just to be definite on the stack. Yeah, something was going on. I shouldn't have mixed the code. So what I'm going to do is I'm just going to put back come on. I'm just gonna put back that code, right? For the pointers there at the top. This code, I'm gonna cut it, then put it there. I'm gonna create a file, right? For you guys so that you can, in case you need the code. So cd downloads. Okay, so let me just create some file called pointer.cpp, and then pointer.cpp. Then I'm just going to say hash include IO_stream int main, then yeah, must not forget to return 0 to denote that this was successful, and then yeah, let's save pointers. So yeah, I've saved that. So yeah, let's continue. I removed that code. Let me put it back. Set it to the value of D, and then C is next. Now point to the address of D because it's no longer the last element. And then D is next. Should now point to null pointer because that's the last element. Then now if you run our code, now okay, I'll just compile it again. Code test.cpp, right? Create an object file called test, and then execute test file. As you can see, A, B, C, D. So we have our nodes. So now let's attempt the question, right? Let's see what the question wants. There we go. So provide code for the templated node structure. We did that. That's what they meant there at the top. So this is and mixing programming languages. It's question 2.4. This is the answer for question 2.4. That's how they want you to create it. So instead of representing one value, it could be an integer, it could be whatever. You're just using a generic type. So you should work with any data type. So I can create linked lists for what is this? Strings, integers, using that same structure, using the same record structure. So provide code for counting and displaying the number of times C occurs in the data structure. Yeah, you're gonna, I feel like 2.5 was the easiest. Yeah, all of them are easy. To be honest, all of them are easy. So basically they want us to count how many times the node C is in the question 2.5. Basically, how many times does C okay? So we need to create a counter first. And we're going to initialize it to 0 using the constructor. And use any approach. You can say it's equal to 0. It doesn't really matter. I just prefer this way of doing it. So I'm going to create a counter. I have to count how many times. So every time I see the value, a node that is the value C, then I increment the counter by 1. And remember what he said. How do you traverse, or how do you go through the node? Create a node pointer, node to store the current node, right? And then that node gets the address that the head is pointing to. Remember what he said. This is heads next. You see this part? This is heads next value, which is the address which is what it points to. It points to A. So therefore, I will now point to A. That's what I'm doing in that one line of code. I'm pointing to the first node. Then now I traverse, I use a while loop. So while my current address, right? Remember that one of these addresses is a null pointer. So while this current address is not equals to null pointer, then I know I haven't reached the end yet. Not equals to null pointer, then I know I haven't reached the end yet. This is very good. So it's very simple. It's like a simple if statement. So let me check my current value, the current node of the value of the current node. So I'm going to say current value if is equals to C. Okay, yeah, I don't have to use curly braces. If it's equal to C, then I've found the node with the C value. So I should increment the counter by 1, like this. And then don't forget to update the address, the current address, to point to the next address. Basically, this is equivalent to saying I++. So you're moving on to the next node. So here you're moving on to the next node. So this is basically the answer for that question. This code. That's all you have to write. And then standard C out. I'm just gonna say C occurs. Then I specify how many times counter. Then I say times. Then I specify it from the standard namespace. Then there we go. Oh yeah, I redefined current. Yeah, since I already have current there, what I'll just do is I'll just do this. I already have current, but in your notes, right, you can redeclare it. That's the best way to do it. Just redeclare it. In my code, I already have a variable or a pointer named current. All I have to do is just update the address of current to point to the start again, right? Then it recalculates. So let me compile it and run it. You see, it occurs 1 times. So there's 1 C in the node, right? So let's say I have 2 C's. Let's just play around with this thing. Let me insert another C value, right? Let's say I insert it after D. So insert or add C again. You see the count will increase by 1. Show you that this code does indeed work. I'm gonna call it another C. New node. And then remember the procedure. Remember D was the last one, right? So I must make sure I update D's next to now point to this C. Because I want to insert it after C, after D, I mean. So I'm going to say another C's value should be what? Should also be C. And then now I need to update D's next to point to the address of C, right? Because D is no longer the last element. And then another C's next address that C should be pointing to should point to null pointer, because the other C that I've added is now the last node. And then we run it again. Segfault, this segfault thing, you keep facing it until let me see. Why is it complaining? Or maybe it has I rushed it. Let me see. Wait, let me see. Okay, another C's value, I made it to be equal to C. And then I changed these next to no longer point to now pointer to now point to another C. And then another C is next to now point to null pointer. Everything should be working perfectly fine. I don't know why it's doing whatever it's doing. Okay, let me do this. This is not the issue though. And this one I'm gonna call it par. Okay. Okay. Why am I getting the segmentation fault error? Let me see. But I feel like now I'm gonna be wasting time because it could be the fact that but it doesn't really matter. I'm just allocating. Yeah, let's just leave it. Let's just leave this whole having to insert again because now I'm not sure what the error is, and I'm not sure what the error is, and I'm gonna waste time. So what I'm going to do is I'm gonna do the other question now. So, but that was supposed to work. I don't know why it's giving me so many errors. So yeah, this is how you're supposed to answer 2.5. You just move the same way you're traversing through the linked list. You just get the current node's value where you currently are. What is its value? You check if it's equals to C. Every time it's equals to C, you increment the counter by 1. And then you move on to the next node. You update the current address to be the address of the next node. It's that straightforward. And then now we need to answer the last question. Provide code for inserting E after the first node that contains D. Oh, I see. There's something that we need to update. This is a secular, linked list. So you see, the last element shouldn't point to now point. It should always point to the head, or it should always point to the heads next, or the first element basically. So this is what I'm going to do. So this it's gonna be very weird, but just bear with me. So now I'm gonna have this node, right, points to this first one. So now what's going to happen is that when you insert the first time, right, the node, the first node's next shouldn't point to null. It should point to itself. I know it's a bit weird, but yeah. So I should update this to this. It should point to itself. It should point to itself. It should no longer point to null pointer because it's a secular list, right? So let's continue. So now I need to update it to now point to B. And then after point, just that, let me see if I don't think I have that shape for, let me see, let me just try something. Yeah. Here, no, it's raw.io, not here. I want to see if I can find it doesn't really matter. I want to see if I can find that shape. An arrow that like sort of like that, an arrow that's shaped like a circle. That's the only way to demonstrate secular thingy, secular linked list. Let me see. I don't see it though. Yeah, it seems like it's not there. Let me see if I can sort of like. Nah, I can. Let me see. Can't I change the shape? Um, properties. Yeah, it's gonna be very. Yeah, it's gonna be very hard to demonstrate it. But let me just show you a simple example. So let's say I have the nodes the way I previously had them. So this would be my node, right? And then I would have the value and an address, right? This is how it was. So let's just imagine the blue part is the value and the pink part is the address. So this is my node, right? So what happens with secular linked list? It doesn't point to null. So it's like, I don't know if you're gonna get it, but yeah, it's like this. No. Come on. It's something like this, right? So it's like, imagine this is an arrow. It's pointing back to itself. Yeah, it's a weird way of, it's a weird, but it has its own applications. If you read the textbook, you would, or if you do your research, you'd find that there is a reason for it. So this is what it means. So every time you add a new node, you must make that new node point to the first element. So it always has to point to the first node, which is A. So, but I'm gonna use the head as a way of pointing to to the first element. I can use A, or I can use heads next. Still the same thing. So A is next. It has to be updated, right? Because now there's a new node. It should point to B, which is exactly how it should be. But then now this pointer here, this one for B, should now point to A, right? It should now point from that side to A. So yeah, that's something that we have to do now. So I'm just going to use the heads next. Because remember, heads next is equal to A, address of A. You could still use A, still fine. Whatever way you want to write it, still fine. And then here, you would have A again. Every time the node is no longer pointed to null, it just points back to the first node. So it's secular, and it's a secular node. So now we have to ask ourselves the question: how are we going to go through the node? So let me see. Do they even ask the question for that? For counting how many times the node in the data structure occurs. So we're gonna, let me see, let me think about it. So we're gonna start from the head, right? And then we move. Yeah, and then I'm just gonna check while the next is not pointing. Yeah, while the node's next is not pointing to the first node, then I should keep moving. So while it's not pointing to, okay, it's a very weird. It's a very weird linked list, but just bear with me. Remember, head.next points to the first node. You can use head.next or A, it doesn't really matter. But I'm just going to use A because A is the first node. So while my current is not pointing, let me see, heads node. Damn, that's going to be interesting. Yeah, because the condition is going to be tricky now. Because I can't use this. Remember the heads node. The heads node is pointing to A, right? So what I think you should do is, okay, we can start from A and then we continue. Okay, it doesn't really matter, but yeah, the question is now how we're going to traverse this linked list. That's the question. Let me think about it. I don't remember doing circular. Yeah, circular is a bit tricky. So let's see, we start from the head, right? We start from the head. The head's next, which is the node A. Therefore, if the node's next is not pointing to A, then I should keep traversing. So what I'll just update this to say, if the next address is not pointing to A, then I'm not back to the first node anymore. I should keep traversing. I should keep moving. And then here I'm just gonna update null pointer to A, because remember now the end is no longer the null pointer. The end is the address of the first node, so which is A. So if I'm not equals to A, then I know I can still output. Okay, I think it won't work now. Yeah, this if statement is definitely not gonna work properly as intended. But let's just try and see if it does build. Yeah, you see, now we're gonna have issues. This whole secular thing it has issues. So let me see. If let me see, let me do this. Let me see if that'll work. It still won't work. So what I'll just do, I'll just output it. I'll just say standard C out current nodes value space, like this. I'll just use a space. Let's just keep it simple. Okay, so it's not even about the space. Yeah, as I was saying, the way you traverse this thing is gonna be very tricky. Let me think about it. No, I shouldn't say current next. I should say current. If current is not pointing to the address of A, but then still that won't work because current, we remember we initialize current to be the address of A, so that won't work. But let me just show you, but this won't work. Yeah, it won't work. So yeah, secular linked lists are a bit tricky. Let's see, let's think about it from a diagram perspective. So if I have the first node pointing to the next node, okay, so the head points to the first node, this one. Let me see. I think we can sort of like trick it and say, I started the head's address itself. And then I say if current is not equals to A, yeah, I can sort of like trick it. Let's see if that will work. So instead of starting at A itself, let me just start at the address of the head. And then I check if current is not equals to A, then we keep traversing, right? And then before I output the value, I must move to the next, I must update the address to be the next node. Because remember, the head's address is just, there's no value for the head because it's just meant to be something to track the value. You see, it's just there. So I can't start by outputting the value. It's gonna try to output the value for head, of which there's no value. So that's why I should move to the next node first before doing anything. And then let's see if this will somewhat work. Okay, it does somewhat work, but yeah, it's not gonna work the way I want it to work. So let me see. So this is a very tricky question. We start from the head, right? Let's just say we start from the heads next. We point here. And then I check the next. If the next, its next is not pointing to A, then keep moving. So let me see if that would work. So let me say we started A, right? Remember, heads next stores the address of A. So if next address, as long as it's not equals to A, then you know that okay, you can still iterate, you can still output values. So let's just check, let's just double check. So it's gonna output the value first, the first value of the current, which is A, and then moves on to the next one. Then it checks if then the next the current node's next is not equals to A. If it's not pointing to A, then it should output a value and then move to the next. But I think it won't output D. Yeah, I think it's still not correct. I think they're gonna output the D. Yeah. Because obviously the letter D is not, the node D is pointing to the next node, but you also still need to output it, right? Oh, I think the another thing that's making this problematic is this code. Let me see the count, right? So what I will do is I'll take out this line. We'll re-implement it after fixing this. Segmentation fault. Why is it saying segmentation fault? Because there's no null pointers here. There's no null pointers. Yeah, this thing is problematic, but yeah, you see, it is kind of somewhat iterating, going through the list, but then the problem is that the last node is not going to be displayed. That's the tricky part. So our formula is not necessarily 100% correct. So let me see. Let's look at the diagram again and see if we can output every value without having to go back to the first element. So what I can do is I can say, I can do it the normal way. We start at A, right? And then while, I don't know why I'm gonna say while, I'm gonna say while it's what? Okay, let's just do this. Let's just say while it's true. Let's create a, just make it, remember that it's a secular thing. Just make it a stuff like, just put it true there. While it's true, right? Remember I start from the, from the current value, which is A. And then from the current node, which is the node A. So before I even try to output the value, what I should do is I should check if my current, let me see, should I say after outputting the value, or after moving? Okay, let me just do it after moving to the next node. I'm just gonna say if current next is, no, let me just say current. Let me not say current. If current is equal to the address of A, then I know now I've went back to A now. But then I don't want, okay, I should say next because I don't want to re-output A's node. So I should just say next like this. And then that should break the loop. If I end up being at A again, then I should break the loop. Let me see if this will work. Or I still need to, okay, still not working. Let me think. So we start from the, we start at the, head, right? Oh, wait, I see now. I'm looking at the next element, right? So what I should do, I think I should check. This is a tricky one. If actually, I think I should check if the current is A, because this is what's going to happen, right? It's going to output A. That's the value, right? It moves on to the next node, which is node B, right? And then it goes back to check the condition, and then it outputs B. Then it's going to move on to the next node, which is C, right? And then check if the node after C, if C's address is pointing to A, then break. At this point, then it's going to be C, it outputs C, and then moves on to the next node, which is B. If B is next, is pointing to A, then break. You see, it breaks before we even output D, the node D. That's another problem that this formula has. I don't want to break when it's equals to. So let me think about it. What if I output the value, right? The current value, which is A, and then I move on to the next. Okay, let me see if I can formulate this thing. Move on to the next node, which is node B. Is the node after B equals to the node A? Okay, let me not say node after. Let me just say current. If current is equals to A, then break. And then, okay, B is not equals to the node A, B is not equals to the node B. The node B is not equals to the node A. And then I go back, I output B, I move to the next node, which is now C. Is C equals to A? No, it's not. Then output C. Then I move to D. Is D equals to A? No, it's not. And then I output D. And then I move to the next node, which is A, right? Because it's a circular node. And then current is A equals to A. Yes, it is equals to then break. Yeah, okay, this is the formula that I'm looking for. And this should work perfectly fine. Yeah, there we go. You just need to sort of like break it down and try to understand the problem that you're trying to solve. There's many ways you can solve it. Someone might come with a better way. There's many ways, but this is how I see it. So how did I come up with this formula? Remember that this one points to the next node, which is B. C points to D, and then D points back to A, right? Then we stop because B is the last node. The last node must always point back to the node at the beginning. So what I did, right, was that I just made the loop just keep running as long as it's true. But then I start here. I started the first node. Remember, it's stored in the heads next. I start with the first node, I output its value. There's the value. And then I move on to the next node, which is B. And then it goes back to the beginning now, back at the top. It checks the condition. Remember, it's always going to be true. So it's going to keep running and running and running. So it outputs the current value, which is B now. and then it checks the current, it moves to the next node, moves to node C, then it outputs the value of node C, and then it moves to the next node, which is node D, and then it moves back to the top, it outputs the value of node D, and then it moves to the next node, which is node A, and then it checks if that node that I've moved to, the current node that I've moved to, is it A? If it is equals to A, then I break. I've went back to the beginning, but I feel like we shouldn't be using the A itself. We should just use heads next. I mean, we created a variable to point to the first node for a reason, right? So use that. Remember the heads next to points to the first node. Yeah, so just use that. And then everything is fine now. Let's work with, let's redo 2.5. At secular nodes, yeah, there's something, there's a bit of a difference. You need to change the bit. So with secular nodes, I'm just gonna do it again, same formula. I'm going to check the current value. If current value, not its next address, its value, if it's equal to C, then increment counter by 1. And then move on to the next node. Move on to the next node, and then I check if my current node points to the first node, and the first node is referenced by the heads next. Remember when we're doing this thing, and there we go. So remember, if it now points back to the beginning, it means that I've reached the last node, so I should break the loop. That's all I'm doing there. Because remember, it's gonna start here, right? It starts here. I move on to the next node, which is this node, B. It moves on to this node, C. It moves on to this node, D. Remember, D points back to A now. So I'm gonna check the node that D is pointing to. If the node that D is pointing to is A, of which is referenced by nodes next, heads next, the node code head, it's next. It's the address of the next element that it's pointing to is the first element. So I'm just gonna reference the first element with head, because I might forget. Let's say I have like 400 nodes. I might forget what was the first node. And as you can see, it's only 62 lines of code here, right? And it's only like 4 nodes. Imagine if there's like 600 nodes. It becomes very problematic. That's why we use head to refer to the first node. It makes it simpler. There we go. I don't know why it's still showing 0 though. It's supposed to increment. Yeah, it's fine though. It's C, right? Capital C. Did I save it as capital C? Yes, I did. While true, right? So we start at the head first. If the current value is equals to C, then increment the counter by 1. And then you move to the next node. Move to the next node. Why isn't it incrementing? Just a bit curious. So what I would do, right? I'm gonna print the values each time. I wanna see if it is actually getting the values or not. I wanna see if it is getting the values. Yeah, something is not okay. You see, it doesn't thingy go to the rest of the elements. I don't know why it's not doing that. Yeah, it doesn't go to the next element. I mean, I did it exactly the same way as this one. You just say value and then you move to the next. After moving to the next, you check if that current is the head next, which is exactly the same thing. So let me just reuse that current variable. Why is it doing this now? It's only going through one value. I mean, I started the heads next. I started the first element, and then I get that A's value and compare it to C, right? That's A's value. Is the letter A equals to C? No, it's not. So it skips this line. And then it outputs that current value, which is A. And then we move current to the next value. And then after moving current to the next value, we check if current is equals to the first node, then break. So you shouldn't be breaking at all. It should be working perfectly fine. Something is not okay here. Why is it not working? Okay, let me just put the curly braces. I don't know. Maybe it could be the if statement and not having curly braces. Doesn't know. I don't know, but I think that's the issue. Because I do move to the next element. There it is here. Move to the next element. See, it's not cooperating. Okay, this is going to be an infinite loop, but I just want to see if I remove that line of code there, what happened. So what's wrong with that condition? Because it's exactly the same as this condition. Check if current is equals to the heads next. Basically, it points to the first element. If it is, then break. This thing, I don't know what was wrong, but now it's fine. So yeah, now it's perfectly full. It's perfectly fine. C occurs 1 times, right? Because there's one C in the node. So yeah, this is the code for 2.5. I will share it with you on the group chat. So let's do version 2.6, right? This is the easy one. It's just inserting, right? And remember that now we are now not working with now pointers, pointing to now. You just point back to the beginning. So if you look at this structure, right? If I want to add a node here, what do? I say new node, so that it creates the new node first, right? So let's do that. So I say node char, and it should be E, right? So I'm going to say pointer E, it goes to a new node of type character, right? We should have the node, the new node itself, right? So imagine there's a circle now here. So there's the circle. I need to update the last node, which is the node D, to point to the new node. Node D is next. So node D is next to point to the new node, which is the address at E. That's the new node's address, right? So now I'm pointing to the new node, right? That's where the pointer is. It's no longer pointing to the beginning. Then update the last node's pointer to point back to the beginning. So the new nodes next point back to the beginning, which is the heads. But then I didn't set the value for E. I must set the value for E. So E's value is going to be E, right? Just E. And then I'm going to output the node after displaying the node after inserting, but you don't have to display. So I'll just demonstrate here. Question 2.6 ends here. Let me just show you where it ends. This is where it should end here. You don't have to display again. I'm just displaying so that we see whether or not it did insert the new values. This error, this error, whatever. It's really annoying. How can I be having a segmentation fault now? Okay, I'll just do this. Always, every time you try to insert some new node, it's always going to be complaining or whatnot. So let me see. The last node was D, right? Yeah. The last node was the node D. So yeah, that should be fine. So I create a new node code E, create a new node, and then set the new node's value to be the letter E, and then update D's next to point to E, right? And then now E's next has to point back to the beginning, which is the head's next. Yeah, of which the address of A is stored inside the head's next. So let me think why it's giving me that error, but yeah, this is the answer. This definitely is the answer. Yeah, when you're writing there, right? Don't worry about these errors. Just write exactly the code the way you think it should be. Don't worry about the actual code, whether it's really running or not. That doesn't really matter. They want to see whether you can change the direction, you know what to update. Because I'm sure on the memo it's exactly like this. It's just that, yeah, the computer, the compiler, you see, compiler is the real issue. Compiler might do things differently and it results in errors and things like that. Come on. Good, let's see. Let's remove it and see if it was still. Okay, it still runs. How come it's not running whenever I try to insert again? Okay, this line, I don't really need it. I just want to check if it's indeed updating or whatever. So let's try it again. I don't know, for some weird reason, sometimes when you rewrite the code, sometimes works. So a new node of type char, right? Create the new node. So the new node is pointing to this address, right, at the moment. So yeah, the new node is pointing to that address. So that's the address for E. It's going to be stored on the heap, allocated on the heap. And then now what I'm going to do is I set E's value now. Let's give it a value. What value is it going to be? It's going to be E, right? Just build to make sure that I don't know. I honestly don't know about these errors now. I don't know why it's doing that. So we have this E, and then I'm going to say these next now point to the address of E, right? Because D is no longer the last node. I need to update its next address, or the address that is pointing to now point to the address of the new node. Then the new node address now should point to the first node, which is stored as heads next. So this is how it's going to be for that question. I don't know why it's doing this. This thing is always unexpected, man. Let me see if I'm gonna get the same issue if I run it in code blocks. Okay, so let's open code blocks and see. Create a new project, console application, pointers. Let me change the theme to this. Okay, where do you say? Oh, I'm supposed to just press OK then. So I press OK. There we go. And then let me say view perspective minimal. Yeah, there we go. Let's build and see. Still the same error, segmentation fault. What segmentation though? Because everything is fine. We're just adding this new node and then, okay, let me just do this. Let me try to rearrange this thing and see. What segmentation error though? I'm trying to see where what it's referring to, because I don't see the error here. There's no error because here we did set it perfectly fine. The heads next is going to point to A. Yeah, it seems like the error it's even in code blocks. So something is not entirely right here, but that's how you'd insert. This is how you'd have to insert at the end of the node. So you just make the E's next point to the first node. That's it. You're done. Unless if the order in the way I did it wasn't proper, but it's fine because all I have to do is just create a new node, give it a value, make this new node's next point to it, and then make that new node's next point to the first element. Because now this node is no longer pointing to the first element. It's going to have the element after it will be the one that points to the element at the beginning. So yeah, this is how I would do it. Why is it giving me an error though? This code is fine. From the way I see it, it's fine. Yeah, I feel like it's fine from the looks of it. Yeah, and it took a lot to just do this question and explain and everything. But yeah, this question is not it's not something that you take lightly. You should be able to do the diagram. If you just do the diagram, just know whenever you're inserting something, you're changing that pointer to point to the new thing, and then that thing, the new thing points to whatever the previous node was pointing to. Look at the previous node, it's pointing to the first element. So node E will have to point back to the first element. That's something we had to make sure we do. Okay, let me see. Or maybe it wants me to do this. Let me do this. Let me just change the structure. Okay, it's still not the issue. Because this, I don't know why this error is there, because this error should okay if I did something like this. You see, if I did this, null pointer, I'm trying to access something that is in no address. So I'm pointing to nowhere. So it should give me segmentation fault. That's normal. Then when I say new node, I don't understand why it's refusing to, why it's saying segmentation fault. Don't understand. So, okay, I'll just continue with this from the next session. I think we're left with question, let me see. We're left with this whole question, DLLs, and the question about queues. So describe how a queue can be implemented using a linked list. So we're also left with this. So we just do this one quickly. Okay, before we do that one, in the next video, I'll just explain, I'll just figure out what this issue is, and then I'll deal with, I'll show you how I fix that part. Okay, thank you. See you in the next session.